Alright, in this video here we're going to be talking about polynomial functions, specifically kind of the definition of a polynomial, what a polynomial function looks like, and then also some of the terminology that we use when we talk about polynomials. Alright, so the basic form of a polynomial function is this: p of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a sub 1 x plus a sub 0, where a sub n, that first thing that's out there in front of that x to the n power, is not equal to 0. All right, so now the a sub n minus 1, a sub 1, a sub 0, those represent some numbers, right? When we have a polynomial, we have numbers multiplied by x's raised to a power. And the powers of the x's have to be non-negative integers, right? So basically positive whole numbers, right? So I have numbers multiplied by x's raised to powers. Those powers are positive whole numbers. I string a bunch of those together with pluses and minuses, I have a polynomial, right? Even if I just have one of those things, even just one number times x raised to a positive whole number power, that's also just still a polynomial, right? So that's what we mean by a polynomial. The subscripts, the n minus 1, 1, 0, those are just index numbers, which we use to just count, right? So a sub n could be any real number other than 0. A sub n minus 1 could be any real number. A sub 1 could be any real number, right? We put the n minus 1 just to count how many we have as we write this form of a polynomial function, right? This general form of a function. All right, so that's what a polynomial looks like. Now, some of the key terms that we use with polynomials. First one, the degree. The degree refers to the highest exponent that we have in our polynomial, which for this one, it's n, right? The x to the n power, and then n minus 1, and so on down to x to the first power, right? So we're counting down the exponents, and that's usually how you see polynomials, is the highest exponent is first, and then it goes in descending order of exponents from there. It doesn't have to be that way, and it's not always that way. So you do have to be careful, because sometimes the highest exponent is hidden somewhere in the middle of the polynomial. But the degree refers to the highest exponent that you have anywhere in your polynomial, right? Coefficients, those a sub n minus 1, a sub 1, all those numbers are what we refer to as coefficients, right? They're the numbers that are multiplying the x's raised to powers, all right? So when we use that term coefficient, that's what we mean. It's a number that's multiplying the variable, right? We have what we call a constant term, right? A constant term is a term, it's a coefficient, it's a number that doesn't have the variable attached to it, right? The numbers that have the variables attached, well, that term can change based on the value of the variable, right? If x is equal to 2, then this term is going to have a different value as opposed to x equal to 3, right? Since it has the variable there, the value of it can change. Whereas the constant term, a sub 0, whatever that number is, no matter what number I choose for x, that number at the end is always going to be the same. It's going to be constant. That's why we call it the constant term, right? Constant means it doesn't change, right? So the constant term is that number that we have at the end without the variable attached. The leading coefficient is a sub n. The leading coefficient is the number that's attached to your x to the highest power, right? We call it the leading coefficient because, like I said, normally we write polynomials in this form where we have the highest exponent first. And so that number that's attached to the x with the highest exponent, that's the first number you see, so we call it the leading coefficient. Now, like I said a couple minutes ago, though, that highest exponent could be somewhere in the middle, right? So the leading coefficient isn't necessarily the first number you see. If the polynomial is written in this standard form, it is, but the leading coefficient could be one of the numbers somewhere in the middle of your polynomial, right? It's not necessarily the first one you see, it's the number attached to the x that has the highest exponent. That gives you your leading coefficient. And then your leading term is that leading coefficient times the x raised to the power, right? So for this polynomial, my leading term would be the a sub n x to the nth power. That's the entire term, the coefficient and the variable of the x that has the highest power. That gives us our leading term, right? And as we'll see in some of the other videos that I'm going to do about polynomials, that leading term tells us some information about what the graph of the polynomial is going to look like. Specifically, whether that leading coefficient is a positive or a negative number, whether our degree, which remember refers to the exponent, whether that degree is an even or an odd number. That gives us some information about the shape of the graph and the direction that the graph is going to go. Right, so the leading term is a very important thing to be able to recognize and pick out when you're looking at a polynomial. And like I said, in some of the other videos that I'm going to do about polynomials, I'll explain the rules that tell us, well, what if this is a positive or a negative number? What if this is an even or an odd degree? What does that actually tell us, right? It will give us some information. All right, so down here we have an example of a polynomial. P of x equals 3x to the fifth plus 6x to the fourth minus 2x to the third plus x squared plus 7x minus 6. All right, so for this particular polynomial, the degree of this polynomial is 5. Right? The highest exponent that I have anywhere in my polynomial is an x to the fifth power, so this one has degree 5. All right, so it's a fifth degree polynomial. That's how we would say that. The coefficients, well, those are the numbers attached to the x's. So the coefficients are 3, 6, negative 2, 1, right? Even though there's not a number in front of the x squared, it's understood that that's 1 times x squared. So 1 is a coefficient, 7, and then negative 6, right? And that negative 6 at the end, that's our constant term. Right, that's the constant because that doesn't have the variable attached. It never varies. It stays the same. It's constant. Right, so again, if I plug in different numbers for x, all these other terms would take on different values. But no matter what number I choose to plug in for x, that negative 6 term is always going to equal negative 6. Right, that's why we call it a constant. All right, the leading coefficient is 3. All right, that's the number attached to my x that has the highest exponent. So my leading coefficient is 3. My leading term is 3x to the fifth power. Right? And again, looking at that 3x to the fifth power, that's going to give me an idea of what the graph of this function is going to look like if I were to actually graph it. All right, so that's what a polynomial looks like, just the general form of a polynomial. This might make a little more sense to you than all this stuff with the a sub n's and the x raised to the n minus 1 power. This is what a polynomial looks like, right? It's numbers multiplied by x's raised to powers. The powers are positive whole numbers, right? So no negative exponents, no fractions, no decimals in the exponents. Just positive whole numbers. The numbers that multiply the x's, the coefficients, those could be fractions or decimals. Those can be positive and negative numbers. That doesn't matter. The exponents, though, have to be positive whole numbers in order for it to be a polynomial. Right? You can write an expression that has a negative exponent and has a fraction in the exponent. That's okay. That's just doesn't fit the definition of what a polynomial is. Right? It can still be a function, just not a polynomial function. All right, so that's what a polynomial looks like. And then when we graph polynomial functions, we have a little space here, so let me draw a couple of graphs for you. The graph of a polynomial function is a smooth and continuous curve. Something that looks like that, right? Smooth meaning, you know what smooth means, right? So it's a smooth curve, meaning it doesn't come into like sharp points or anything like that. This would be a polynomial. Right, this graph here would be the graph of a polynomial function. It's smooth and it's continuous. Right, continuous meaning there's no gaps, there's no hole in the graph. Each point is connected to the next point. That's what we mean by continuous. Smooth meaning it doesn't come to any sharp points or anything like that. So the graph of every polynomial function is going to be a smooth and continuous curve. Right, a graph of something that is not a polynomial, or a graph that would not be a polynomial function might be one that looks like this. Right? This sharp point that it comes to up here, that's not smooth, right? That's sharp, and so that is not the graph of a polynomial function. It's still the graph of some function, just not a polynomial function, right? Because it doesn't have that point there is not smooth when it comes to that sharp point. So anytime we come to a cusp like that or a corner, we don't have the graph of a polynomial. And also one other thing that makes it not be a polynomial, if our graph is not continuous, right? If there's like a gap in the graph or a hole in the graph, that's not going to be the graph of a polynomial function. Right? Again, it still could be a function, just not a polynomial function. All right, so that's some of the basics of the definition of a polynomial, some of the terminology we use. It's important to understand these terms. Like when we talk about polynomials, we use the words degree and coefficients and constant and leading coefficient. We use those words all the time, so it's important to have some understanding of what those words actually mean. All right, so that's it for this video. I'm going to do some other videos where I talk about polynomials and some of the things in a polynomial that tell us what the graph is going to look like, and let us figure out how to graph a polynomial function. So make sure you check out all those other videos that I'm going to do also on polynomials.